Hello friends, welcome to Coding Garden. Welcome to Web Security Wednesdays, where today we're going to be focusing on cross-site scripting, or also referred to as XSS. And so we're going to talk about what it is, what are the kinds of XSS you might come across, how do we prevent it and fix it, and other various questions that might come up in the Twitch chat. First up, what is XSS? So we already mentioned it stands for cross-site scripting, and this is a vulnerability in a website that allows an attacker to execute malicious code on someone else's website. XSS attacks enable attackers to inject client-side scripts. That's a good distinction to make. You're essentially injecting scripts into a web page, not into the server, but into the web page. So that's what it is. I think the best way to really show you what it is to show an example of where something might be vulnerable. First, we'll do it with this XSS game. You can actually go to this URL, xss-game.appspot.com. This was created by Google to kind of teach about XSS, and also you can practice doing it. So we'll do the first challenge here where you can see where a potential injection comes from. This little input box here is vulnerable to cross-site scripting. If we look at the actual source code for how this page works, right here is where they are vulnerable to cross-site scripting. So you'll see when they render the page, they take whatever the user typed in and then render it directly right there in the page. So if I got clever and I did something like this image, which will break, the on-error event will get triggered and will actually execute the code right here. So if I do this, look at that. We've gotten an alert box to pop up. And you'll notice that that actual injection gets reflected in the actual URL. So your average user isn't going to want to run scripts against themselves. They could just open the dev tools if they wanted to do something like that. But the reason this vulnerability is especially bad is I could take this URL, share it with anyone, and now if they go to that URL, I'm now running JavaScript in the context of that specific user. So for example, if there was like a phishing attack where I sent this link to the admin of the website, and then when they go there, they're logged in as admin, because I can run whatever script I want. Right now I'm just showing alert as an example, but I could have literally any JavaScript I want right there. I could write some code that steals things from local storage or makes requests on behalf of that user because it is running as that user. Yeah, and phishing with a PH, exactly. So this is your first example of cross-site scripting. Essentially, the developer of this website has not sanitized the user input, and it gets directly rendered on the page, making it so that scripts that were not intended to be run on the page can be run on the page. What we just showed is reflected cross-site scripting. It essentially is using information from the URL to then be rendered and served onto the page. There's a few good resources I have here that talk about what cross-site scripting is. The first one is from the OWASP website itself, and they talk about the different types. So a reflected attack are those where the injected script is reflected off of the web server, such as in an error message, search result, or any other response that includes some or all of the input sent to the server as part of the request. And so in this case, the server is reflecting that image that I injected back to the rendered page. So that's an example of a reflected attack. There are also stored attacks. And so this is where maybe there is a description for your profile. And let's say you go into your profile and you put an attempt to exploit a cross-site scripting vulnerability in your description of your profile. What could happen is now that potential exploit is stored in a database, and then when someone else comes along to the website and visits your profile, if the page is not sanitizing the description, it'll potentially run that script that you have there in your description. So that's an example of a stored attack. It doesn't necessarily need the URL to inject something into the page. It's stored in a database somewhere, and then when someone visits the page, it runs that script. A good example of this is actually in this article from sneak.io. They have a bunch of really good articles on a lot of security topics. Specifically, they have one on cross-site scripting, and you'll see this first attack that they described, which actually was a cross-site scripting vulnerability on Twitter. And so this was an example of a stored cross-site scripting vulnerability because a user sent this tweet that gets stored on Twitter servers, and then anyone that views this tweet now runs the script that was the tweet itself. So it had to do with the way that Twitter was parsing emojis. Regularly, like Twitter, a huge website, would not want to be vulnerable to cross-site scripting. So if you attempt to make a tweet like this, even if you're allowed to, it's not going to be vulnerable right now, unless you find an edge case like this, where if your message includes an emoji, for some reason it wasn't getting sanitized in the right way. So this is an example of a very big company, a very big website that were vulnerable. So the person that sent this tweet, essentially anybody that comes and views their tweet would have seen an alert on their web page. But to make it worse, anybody that viewed their tweet would automatically retweet their tweet. And it actually brought the website down, because you can imagine how this could just quickly grow really, really quickly to send so many requests to Twitter servers, where a person tweets, but the malicious code is code that will in turn retweet the current tweet. And then anybody that views that will retweet it. And then anybody that views that retweet will potentially retweet the retweet. And everyone was just retweeting the same tweet. And so it brought the site down. So this is an example of it happening in the real world, which is why we don't want to be vulnerable to this. So yeah, we talked about reflected. We also talked about a stored attack. And so this is an example of a stored attack. This is an example of a reflected attack because it's reflecting it in the URL there. Nothing says in the wild, most common cross-site scripting is blind and cache-based. And that's a good point to bring up, because that's the other one that I didn't talk about yet, which is blind cross-site scripting. So, and that is, you have no idea if the code you're attempting to inject is going to be run somewhere. You just kind of like hope and pray. And so it's similar to stored in that you're potentially updating values that you have access to, like on your user profile or anything else that you might have access to make updates for that gets stored somewhere. And then you're just hoping that a user with privileges will go to a page that potentially runs the code that was part of the exploit. And so that's known as a blind attack. Okay, so these are the kinds of cross-site scripting. Let's jump into how do we prevent it? How do we fix it? And then also look at some scenarios where you will be potentially vulnerable to cross-site scripting. I think I need to just create an example locally to really show where we're vulnerable here. Okay, so you go to this page, you search for something like banana, you click enter, that then reloads the page and it tells us on the page what we searched for. And so this is a classic example of being vulnerable to cross-site scripting, because I am not sanitizing that search query param right there. I'm literally injecting it directly into the page. So a curious person would be like, oh, well, let's test the limits of this. What can I put in there? Could I add an image? And will it actually render on the page? I searched for a kitten. So this is bad news. If you can actually see rendered elements, you definitely know that the page is vulnerable to it. Yeah, you could do literally whatever you want. You could embed a Google map. You could do a bunch more stuff here. But let's show the classic example of how we can execute some scripts here. Now, you might actually be tempted to inject a script directly, but these days a lot of browsers will prevent you just from injecting a script directly with setting innerHTML. So let's try this and let's see if this works. Yeah, this doesn't work. And if we look at the actual rendered page, we can see that the script is there, but the browser is actually preventing that from executing because it was set here with innerHTML. And so let's learn one of the ways to prevent this, which is don't directly include user input in the HTML. We'll call this one vulnerable. User input directly set in HTML. But let's show an example where we don't do that. So what we might do is something like this. So we set the innerHTML to stuff that does not include user input, and then we can create an element and set its text content. So we can say the search term element is a div. And then from there, we can set the inner text or text content. I always just default to text content. Essentially what I've done is I've created an element. I've set the text content. You'll notice we're not setting HTML. We're just setting text content. And this actually takes that and places it as the text content of the element, which doesn't get rendered as an image or whatever element it might be. And then now that I have this element, I need to append it to the example element. So I can just say example element.append and then append that search element. And just like that, we're no longer vulnerable. So because we're not setting innerHTML here, we're literally just putting it onto the page. Now we're not actually trying to render that content that came from a user provided value. This is not vulnerable because it uses node text instead of HTML. And the thing to note here is node text does not render content. It only displays it. The next thing you could do is sanitize your input here. And this example is nice because we can continue to do like the innerHTML thing that we were doing before, but we will sanitize that search value when we're setting it here on the search element. But we need a sanitize function. So we might have a function here called sanitize HTML. And you might just think, let's just replace every occurrence of a less than or a greater than. We'll do this globally, and we'll rescrape it with not this time, hacker. But basically, we're stripping out the less thans and the greater thans. And by doing that, now we're just adding it there without the less thans and the greater thans. So we need to actually call our function right here. There we go. Not this time, hacker. It's not vulnerable mostly because there's more to think about than just less thans and greater thans. And then there are other scenarios where it will be potentially inserted into the DOM where it doesn't really even need less thans or greater thans. For example, if it was an attribute itself. So let's actually introduce another vulnerability where we put it on the attribute right here. And we say, like, let's say we're adding a tooltip on the title right here. And if we put the search term right here, but now we've introduced a different place. Now, I'll even show you, even if we pass this in here, I can exploit this because I'm a hacker man. Now let's try to exploit this. And let's think about it, right? If we're literally taking that and putting it into the page right there, what could we do? Right? Basically, we could break out of the title attribute, right? So like if I said the search term was something like close quote space, I don't know if we have onload. Let's try it. And then there's like another double quote like this. And so basically I'm going to attempt to inject this right there. And you'll notice it doesn't have any less thans or greater thans. Let's see what happens. So if we look at the actual what gets rendered here, you'll notice it actually did put that attribute onto the page. But one thing you could do is like mouse enter. So like this is a DOM event that can be added directly. And now, is it on mouse enter? Let's try it. There we go. Oh yeah, and now it says pwn. So the moment my mouse enters, it actually runs the code. This isn't ideal because this requires more user interaction, but we still technically have injected. We're in. We've still technically injected some codes. And so really the only point I'm trying to make here is there are a lot of different scenarios that you have to think about that would require a lot of our own code, which is basically why I'm saying don't do this. Don't just write a simple little replacer to prevent injection. You want to use a tried and true, tested, security hardened library that has handled all of the edge cases and has a bug reporting program where people find bugs in it and they get fixed quickly. Okay, so the last example is to use a library. So we're going to use DOMPurify. But yeah, look at this. 12,000 stars, only one open issue, updated yesterday. Here we go, DOMPurify.sanitize. And let's just use the defaults and see what happens. So right here, this. Cool. So now you'll notice it's purifying it, and let's see what it actually is adding to the page. It is getting added right here, but you'll notice it's stripping out the on error attribute. There are more options in the library to say what attributes do we want to allow and stuff like that. Yeah, and then you could also, the other attribute here is you could run it on the server. And so this running it on the server is one way to prevent stored attacks. If you're always running it on the client, you're at least preventing it from running on the page itself. But if you run it on the server before you put it into your database, you're less likely to have a stored attack because it gets stored purified without all the extra stuff. Yeah, here's some more options. Like you can specify allowed tags. Like let's say you want to allow people to use paragraph tags and stuff like that. Then this uses an allow list, and anything that's not in the allow list will not be rendered. And let's actually do this. So because let's say you did want to use DOMPurify for something like Markdown or something like that. You could use a Markdown library, potentially a Markdown library that doesn't do any sanitization, generate the Markdown, and then pass it to DOMPurify and say, hey, don't allow scripts. Basically, the only thing you should allow are like text elements. So if we do allowed tags like p tags and like h1s or something like this, now that image tag is going to get stripped out. So now it doesn't render anything at all. And so you would definitely want to look into this library to make sure you're doing the right things according to your application. So in this case, you'll notice because I tried to inject an image tag, it just stripped it out entirely. It's only going to allow p tags and h1s. And technically, now we can do fun stuff like this. Woo! And it actually gets rendered on the page, but that's because the application has allowed it, and you mostly can't do anything harmful with those two like text elements. The other thing is it has options for tags. So you can do forbidden tags, forbidden attributes, or you could do like allowed tags or allowed attributes. Yeah, allowed atter. But we could pass this in as nothing. And so you can do P1s and H1s, but strip out any attributes, and that's handled there as well. But you should definitely look into the docs for this library, make sure you're using it in the intended ways, and you're only allowing things that you actually want to allow. Ultimately, the way that you prevent it is by first avoiding using innerHTML on user-provided input. So this is anything coming from a user. In our case, it's just whatever the user typed into the search box. That's the user-provided input. But user-provided input is also things that people are setting values in their profile, or if you have a website where a user can create things like create a post of some kind or a comment, that's also user-provided input. Basically, we should never trust anything coming from users, because hackers at the end of the day are just users of your application. They're malicious users because they have malicious intent, but they are also just using the same application that everyone else is using. And so if you basically trust no one, that's the best scenario there, where regardless of what it is, if it's coming from a user, you always sanitize it and you never put it somewhere where it could be directly rendered. That's the number one key here. And this is the same advice to handle SQL injection, to handle command injection. Just never ever trust what the user is sending you at. And so specifically, if we're talking about DOM manipulation here, not using innerHTML is kind of key. Like I avoid innerHTML. Absolutely. I potentially use like a template engine, but then also if there is and this is also if I'm not using a front end framework like Vue or Svelte or React or something like that, because we'll talk about those next. Those automatically handle this sanitizing, and it handles it in the framework itself, unless you try to break out of it, which I'll show next. But yeah, just don't use innerHTML basically. Like if you know that if you're not using user provided input, innerHTML is totally fine, but the moment you start to add variables in there that came from a user, that's when you're going to run into trouble. The best advice here, and this is what I typically do, is just use textContent or inner text. This will never be rendered on the page. It always is just the text itself, and it gets just displayed on the page. It's never going to get rendered if you use textContent or inner text. You're basically guaranteed to not be vulnerable if you use either of those two. And then the last bit of advice is don't try to implement your own sanitizer function. There's just too many potential scenarios that you probably haven't thought about. You could try it, but you are better off if you use a tried and true tested library. But yeah, so DOMPurify should do nothing to your previous cross-site scripting attack in title. I guess we'll try it. So if I close it out like this, yeah, you're completely right. At this point, we're actually still vulnerable to we're still vulnerable to attribute injection. How do we prevent this? Yeah, thank you, Andrew, for mentioning that. We'd have to think about this. Like, what would we need to do here to make sure that we're not vulnerable to attribute injection? Using set attribute, that's probably a good idea as well, like this. So we have this, and then we have the user search element. So we manually create a div. We do set attribute title, and we set that to be what they passed in. And then from there, if we still want to use the HTML, we can do user element.innerHTML and set that equal to DOMPurify sanitize. So this is how I would prevent the attribute injection, because set attribute should escape our input here. And at this point, we can append the user search element to the example element. Let's see. Yeah, okay. When I use set attribute, you'll notice how it's purple. It's actually being set as the string for title. Cool. Let's keep moving. This was fun. I'll answer any of the other questions that you might have, and I think I'll show some examples of having this vulnerability like in a React or a Vue app. I think that's what I'll do next. Let's make a React example. We're just going to create a little Vite app and then show how we would be vulnerable with React. This is scary. I'm a web dev, and I'm scared of things that hackers can do to me. Well, the best thing you can do right now is be informed, right? So that's basically what I'm doing, is I'm making people aware of these things so you can think about them when you're building your application. And what I'll show you is if you use something like React, you're mostly protected unless you try to escape out of their protections, and that's when you're going to be vulnerable. So that's what I'm going to show you here. Okay, if there was a search term, show this text that says you search for and put their search term right there. Otherwise, we're going to render the form so that the user can search. Here we go. So now let's try the classic vulnerability where we have we try to load an image and then specify the on error. And let's see, are we vulnerable inside of React? We are not. And we didn't have to do anything, right? You'll notice I'm not calling DOMPurify. Even here, if I try to set the title to search, this one will not be vulnerable to attribute injection. Absolutely not. So now if we look at this, you'll notice that it just all gets put into the attribute there. There's no way to break out. I mean, I can try breaking out. So again, if we do, yeah, there's no way to break out. There's not even double quotes here. But if we assume that, okay, let's say I do a double quote to close it out, and then we try to add our own little on click, and then we need to close out the other attribute. You'll notice the way that React and the virtual DOM are rendering these things, all of that content is just the attribute text. Under the hood, it's using set attribute. We're not going to be able to break out from there. So by default, just using React, we're not vulnerable. But what I want to point at is the one place where we would be vulnerable is if we decide to use dangerously set inner HTML. So if we did something like this, dangerously set inner HTML, like this. Okay, so now if we were to basically break out of the protections that React gives us with dangerously set inner HTML, now we are going to be vulnerable. We're absolutely going to be vulnerable. Because we explicitly said, hey, we want to set the inner HTML, and that is why they actually call their attribute dangerously set inner HTML. If you have a linter set up, pretty often you'll have a rule, like a React linting rule that says, hey, don't do this. You could combine this with DOMPurify, so that's another option. Let's install DOMPurify in this project. What are the valid reasons? Yeah, so if you're doing things like markdown rendering, or like even if you're building, let's say, a blog, like sometimes you do want to render user provided content. Sometimes you do want to render like p tags and title tags and different things like that. But you don't want to allow scripts or canvases or anything else that will potentially allow for other executions of codes. So in this directory, in this React app, I can install DOMPurify, and then we can import it in. Yeah, and I guess like sometimes maybe even, I mean, it's hard to say, but if you're building an internal application and you know the only people that can ever run that application or ever have access to it are trusted users, maybe at that point you can say, all right, we're not going to purify anything. But I would argue that you can't ever guarantee that, because that's another potential attack vector. Because let's say a hacker gets into your systems and internal systems and then gets access to that app where you weren't sanitizing user inputs. Now they could maliciously inject something. So like you can never truly trust all the users of your app. Bad coworkers, disgruntled coworkers, insider threats. Exactly. Okay. So now at this point, I'm breaking out of dangerously set inner HTML, or with dangerously set inner HTML, but I'm using DOMPurify sanitize just to be sure. And now, there we go. This is still vulnerable. Why is this still vulnerable? Oh, because we didn't disallow images. It sanitized it, but I think when it sanitized it, it just removes the on error attribute. So if we pass in an image and it has an error, we won't be vulnerable to this, because by default, DOMPurify is going to strip that out. Yeah, so by default, we pass that in, and it stripped out the on error attribute. But again, like I showed in the vanilla example, you could specify what do you want to allow, what do you not want to allow, that kind of thing. How to be fully secure? Just don't build the app. Yeah, I guess don't even. Just go live in the woods, basically. And yeah, I think this is a great summary from Lava in the Lamp. Good rule of thumb, avoid using this, but if you do have to use it, you should still be using a sanitization library as well. And ultimately, if you're using user-provided input, right? If this is coming from a user, you should sanitize it. Plain and simple. In 20 years, will we still use UI? I don't know. Hopefully by then we can control things with our brains, but maybe not. I've thought about this a lot. A lot when I was younger, like imagining like the sci-fi future, and like, oh yeah, one day we're all going to have our brains uploaded to the cloud, and then we'll never die. But what you don't think about is that who owns the cloud? It's Amazon, and so at that point, Amazon owns your consciousness. And I guess the same thing, like if I'm getting a brain implant to be able to control computers with my brain. What company made the brain implant, and are they in control of things? Are they like servicing me ads? Are they in control of my dreams? Yeah. Is this just web dev or any programming language? any programming language that will be potentially rendering content to be loaded into a web browser. A good example of that is this XSS game. It's interesting to show because when they show you the source code, they are showing you the backend source code. Like there's a server that's actually serving up this page. And the reason Python needs to be worried here is because if you're if let's say you're using a framework within Python that allows for rendering web pages, you should be sanitizing any user input if you're injecting user input into the rendered page. Even if you're not working with JavaScript on the front end directly, you still need to worry about cross-site scripting if you're building backend applications that render client applications. The thing that I didn't talk about earlier is, like scanners and static code analysis, but basically these are tools you can run that will identify places in your code where you might be doing something that's vulnerable to cross-site scripting. Like, for example, ESLint has a rule that says you shouldn't use this anywhere in your React app. And if you enable that rule, now you have this tooling that's basically there to let you know that, hey, you're doing something that could be vulnerable. Okay, that's it. That's all. Thanks for watching this. Ultimately, I think I want you to walk away with, first of all, knowing that XSS is the thing. And then now that you know about it, make sure that the applications that you build are not vulnerable to it, and at least try to check and see if they are vulnerable. I mentioned some things that you should avoid doing if you're working in a front-end framework, because these are really the main areas where you're going to expose yourself to cross-site scripting if you're working in a front-end framework. So ultimately, if you do need to use dangerously set innerHTML or VHTML or add-HTML, make sure you're at least sanitizing the user input with a library like DOMPurify. And the ultimate takeaway here is always, always, always sanitize user-provided input. You can't trust any user at all, and you should always sanitize any input you got from a user that you're potentially adding to a web page. So thanks for watching this video. We'll see you in the next one.